Hello world! My name is Kasia Hevelt and I'm a data scientist at Codilime. Retrieval Augmented Generation, or RAG for short, or function calling. Today we are discussing these two techniques that help enrich large language models' knowledge. Let's start with LLM. What is an LLM? It's a large language model. Essentially, it's a computer program trained on vast amount of text data, allowing it to predict and generate text based on the input it receives. LLMs can learn the nuances of language, grammar, facts about the word, and even some reasoning abilities from diverse datasets like books and articles. They are used in chatbots, content creation, translation services, and even assisting with programming. While powerful, LLMs can also produce incorrect information because they mimic patterns rather than truly understand language. They represent a significant advancement in AI, providing tools that process and generate language with impressive fluency. However, LLMs don't have specific knowledge about recent events or specialized information like latest research, current weather, or our very own resources. And this is where techniques like RAG and function calling come in to enhance their capabilities. Using these techniques, we can connect LLMs to external data sources, enabling them to access and utilize the most relevant and up-to-date information. This makes our applications much more powerful and useful. For instance, imagine developing a support chatbot that not only understands and responds to general queries, but also fetches specific information from your internal databases, recent documents, or live data from your CRM platform. RAG allows the model to retrieve relevant documents or data points, while function calling enables the model to execute specific functions, such as querying a database or calling an API to get real-time data. Now let's first explain the architecture of RAG. RAG is designed, of course, to enhance the capabilities of large language models by combining them with information retrieval systems. Here's a brief overview how it works. So RAG works first by chunking your data into smaller, manageable pieces, as large language models cannot process everything at once. It depends on the length of your document and the length of the context window, so keep that in mind. These chunks are then converted into embeddings, which are vectors representing the data. These embeddings are stored in a vector database, creating a knowledge base from your own documents. When you pose a question, the system computes embeddings for the query as well. Using semantic search, the system finds the most relevant chunks of information from the vector database to provide context. This context is then passed to the LLM, which formulates the final response. This process allows the model to provide specific and up-to-date information by leveraging your external data sources. To see how this works in practice, I'll now show you a demo example with the code. Our RAG demo. First, the code starts by importing the necessary libraries and modules. It also loads the environment variables from the env file and sends the OpenAI API key, as this is the model we are going to use. Then we do have PyPDF loader, which is used to load the PDF documents specified with the file path. Here we have a sample PDF file. This is this one, Annual Status Report 2022 Global Projects for Managing Development Cooperation Effectively. This is a sample document just for the demo purposes. It's quite lengthy, but we can technically ask any question regarding this document while we implement this method. Okay, once we load our document, now it's the time to split it. Split it into the chunks. Here we have chunk size and chunk overlap. This is where we specify how big of a small pieces of text we want to have. As some models digest less characters, less tokens, then I've chosen 2000 just to be safe. However, keep in mind that the most advanced models right now can digest even over 100,000 tokens. Okay, but let's just keep it like that at the moment. Let's also have a look at the data. Let's just put chunk number 1. And we can see in 2000, yeah, this is the text, of course, from our report from the very beginning in 2022, etc. Okay, once we have our chunks, once we chunk our document, then OpenAI embeddings are initialized, and a Chroma vector start is created from the document and from our embeddings. This process might take some time. This document is not that lengthy, so it wasn't that long, but keep in mind that this one can take some time. Okay, and the next step is to define the prompt template. You are an AI assistant that answers questions about loaded PDF file using only provided context. If you don't know the answer based on the given context, simply state that you don't have enough information to answer. This template is to avoid hallucinations. We don't want an LLM to use its knowledge or just make up the information. We want our LLM to rely on the document we provide. And once we have it, we also initialize the LLM. Here I've chosen the newest OpenAI model. And we are almost ready to post our question. A retrieval-based question answering system is created by using Retrieval QA. It combines large language model, retrieval meaning retriever meaning the vector store, and the prompt template we just specify. And the last step, we can already post the questions. In the final output, I also included the source document. So here we have the question itself, the result, and the documents the LLM used to provide this answer. Now let's talk about function calling, another very powerful technique to enhance large language models. Function calling allows LLMs to execute specific functions during their operation, enabling them to interact with external systems and perform tasks that go beyond simple text generation. Here is how it works. First, we define the functions that the LLM can call. These could be anything from querying a database, making an API call, or executing a specific task in an application like Jira or CRM systems. When the LLM processes a user query, it identifies if a function needs to be called to provide a complete and accurate response. This decision can be based on the context and specific keywords in the query. If a function call is needed, the LLM triggers the predefined function. For example, if a user asks for a latest sales report, the LLM might call a function that queries the sales database and retrieves the latest figures. The results from the functions are then integrated back into LLM processing the pipeline. The model uses this real-time data to generate a response that includes the latest and most relevant information. Finally, LLM formulates and delivers a response to the user enriched with the real-time data obtained from the function call. Function calling is particularly useful for tasks that require real-time information retrieval, dynamic data access, or interaction with other software systems. It expands the capabilities of LLMs by allowing them to perform specific, actionable tasks based on user queries. All right, function calling. We are going to demonstrate how to connect with Salesforce. Of course, you can connect with external APIs such as like weather checker or flights information, currencies, etc. I am choosing today for the demo purposes sample data on the Salesforce. Salesforce is a CRM platform, customer relationship management, where you can track your deals with customers, when you can add some activities to these deals, etc. This is sample data about the deals. Okay, so how does it work? I am working with OpenAI API, and firstly, I am asking the question, what are my deals in Salesforce? OpenAI models are trained on vast amount of data, but 100% it does not have the access to the knowledge about my deals in my Salesforce platform. However, we are getting the information how to access this information. To view your deals in Salesforce, you follow these steps. So the whole instruction, how to do it, but we would like to connect this data with our LLM. How to do that? So firstly, we specify our credentials to Salesforce platform, and then we are creating functions which are going to call which are going to retrieve the information from our Salesforce. These are two methods, SOSL and SOQL, and the first one is using the specific information by using the string, search string, and the second one is very similar to querying a relational database as the information stored in Salesforce are like a relational database. Okay, the next step is providing function descriptions, where we provide name, description, and the parameters for these two functions we specify in the previous step. And the whole sauce is happening now. So what is happening? We are again using the newest GPT model from OpenAI, and the model, we are providing the functions we specified before, and right now asking exactly the same question, what are my deals in Salesforce? And what is happening now, the model and the LLM, by the keywords provided in the prompt in a question, the model is looking for the appropriate function. Here we have function called auto, meaning the model will find the function by itself. And once this is done, we are providing the output of the function into the model, and here are your deals, opportunities in Salesforce, opportunity name, example deal 1, or example deal 2, etc. So here it is how it works with function calling. So when do we use RAG? When do we use function calling? Well, it depends. Use RAG when you need to incorporate extensive background information from large static datasets. For instance, if you have a vast repository of documents, reports, or historical data that the model needs to reference to provide comprehensive answers, RAG is the ideal choice. Function calling, on the other hand, use it when you require real-time data or need to perform specific actions. This technique is ideal for scenarios where the model needs to interact with other systems, fetch current data, or execute predefined tasks. You can also combine RAG and function calling. Sometimes this is the best approach. You might use RAG to retrieve background information and function calling to fetch real-time data, creating a comprehensive and up-to-date response. The example scenario would be, imagine a customer service bot that needs to provide detailed product information using RAG and also check current inventory levels using function calling. By combining both techniques, the bot can deliver well-rounded and accurate answers. In summary, the choice between RAG and function calling depends on your specific needs, on your specific use cases, whether you require extensive background information from static sources or dynamic real-time data from external systems. Understanding the strengths of each technique allows you to build more effective and intelligent LLM-driven applications. I hope now you have a better understanding of the differences between RAG and function calling and how each technique contributes to enhancing the capabilities of large language models. Thank you for watching and stay tuned for more insights on AI technologies.